Hi students, in this video we're going to cover the product rule and the quotient rule. So we use the product rule and the quotient rule to derive functions that can't be simplified by multiplying or dividing. Um, Even though the examples that we're going to use can sometimes be multiplied or divided, it's easiest to see this in practice with very simple functions. And generally, we're using this as a springboard to the chain rule, which is how we calculate the derivatives of composite functions. So we're going to start out with very basic binomials and polynomials to illustrate this concept. So we have this function x squared plus 1 times x squared minus x right here. Now we can actually just multiply this out and get x to the fourth minus x cubed plus x squared minus x. And from there, you can calculate the derivative to get 4x cubed minus 3x squared plus 2x minus 1. If you've not watched the video of how we derive these simple polynomials, go back and rewatch that. So we can also use the product rule to derive that function, and we'll see that in a moment. Now, generally, we're going to reserve the product rule for functions like x cubed times sine x or something like tangent x times sine x, because you can't meaningfully rewrite those into something that's easily derived. And a huge note here is that if you have a constant times a function, you don't have to do a product rule. So if we had a function like f of x equals 4 times sine x. That doesn't require the product rule. The derivative of that is just 4 cosine x. Now you can do the product rule and you should still get 4 sine x. It just does not require the product rule. So in general, if f of x is a function that's the product of two other functions, then its derivative is the derivative of one function multiplied by the other function plus the second function plus the first function multiplied by the derivative of the second function. Let's label these functions 1 and 2, for instance. So we'll call this function 1, we'll call it function 2. So what we have is d1 times 2 plus 1 times d2. And we're going to say d stands for derivative. So the derivative of the first function times the second plus the first function times the derivative of the second function. Huge disclaimer. The product rule is not the derivative of one function times the derivative of the other function. It's not true. So don't do that. For the first example, we have to find the derivative of the function. So now again, we could just multiply this out because it's just one binomial times another binomial. But what we're going to do is use the product rule. So first we're going to take a nice rewrite step. And this is going to be equal to x minus x to the negative 1 times x squared plus 1. Now, according to the product rule, what we should do is the derivative of the first function. So that's going to be 1 minus 1 plus x to the negative 2 times the second function. So we got 1, we got 2. The second function is x squared plus 1, then plus the first function, which is just x minus x to the negative 1, multiplied by the derivative of the second function, which is 2x. Remember, the derivative of a constant by itself is 0. So now we get this as our derivative. Now, if you want to, from here, you can like multiply things out. We will get x squared plus 1. So x squared plus 1, and then x to the negative 2 times x squared is going to be another plus 1, and then plus x to the negative 2. Then we're going to have plus 2x squared, and then 2x times x to the negative 1 is just going to be minus 2. So if we simplify that, we get 3x squared plus 2 minus 2. So 3x squared plus 1 over x squared. That's what we get simplified. All right. For part B, we have g of x is x cubed times sine x. So this is already set for the product rule. So you're going to have the derivative of the first function, which is 3x squared, times sine x. So again, we have our 1 and our 2. So then plus x cubed times the derivative of sine x, which is cosine x. Now, whenever possible, maybe factor out a common factor. In this case, they have x squared in common. So we're going to have x squared times 3x sine, I'm sorry, nope. We have x squared times 3 sine x plus x cosine x. But again, not necessary, just looks nicer. So then part C, we have three things multiplied. So how do we do that? Well, what we can do is consider two of the things to be one function. So we'll say we have x sine x is one function, and then cosine x is another function. So still using the product rule. So h prime of x is going to equal, now according to the product rule, is the derivative of the first function. So this is our 1, and this is our 2. So the derivative of x sine x itself requires the product rule. So that's going to be 1 times sine x plus x times cosine x. That's the derivative of the first function. So x means sine x plus x cosine x. And then we're going to multiply that by cosine x. Then we're going to have plus x sine x multiplied by the derivative of cosine x, which is negative sine x, not minus sine x, times negative sine x. So if we distribute, we're going to have cosine x sine x. I guess we could have written sine x cosine x. Doesn't really matter. We'll rewrite. So all we're doing is distributing the cosine to both terms. Excuse me. So we're going to have sine x cosine x plus x cosine squared x plus, well, minus x sine squared x. And that is as far as we can go, kids. So we'll stop there. Like the product rule, the quotient rule is going to be used, well, similar to the product rule. The quotient rule is used to derive rational functions and expressions that can't be simplified. So if we had like x plus 1 divided by x squared, it's easy to rewrite that as x to the negative 1 plus x to the negative 2, and then you find the derivative. But if you just took the reciprocal of that function and have x squared divided by x squared divided by x plus 1, you cannot say that is x squared divided by x plus x squared divided by 1. That is not true. So for these kinds of functions, we use the quotient rule. Now the quotient rule, it looks like a handful. If we look at f of x as the numerator and g of x as the denominator, the quotient rule is going to tell us that we have the derivative, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. And we don't ever really want to multiply out our denominator. Doing so is going to create more work for us and not give us anything that's very meaningful. So when we derive this, we're never going to really multiply out our denominator. We'll just leave it be. So for example 2, we're going to derive this function, and it's x squared. It's the function that we started with. So we're going to have h prime of x is equal to, so according to our rule, it's the denominator, which is x plus 1, times the derivative of the numerator, which is 2x, minus the numerator times the derivative of the denominator, divided by the denominator squared. And if we rewrite this, we're going to get 2x squared plus 2x minus x squared divided by x plus 1 squared. And then if we simplify that, we're going to get x squared plus 2x divided by x plus 1 squared. And so again, don't multiply this out because you won't get anything generally that is going to allow you to cancel. So that's the derivative. For letter B, we have secant x. So secant x is the same as the function 1 divided by cosine x. So we're going to use the quotient rule to get its derivative. And after that, we're just going to remember it. You won't have to do the quotient rule every time. So according to the quotient rule, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which is negative sine x, and then divided by the denominator squared. So this is going to give us cosine times 0 is 0, negative 1 times negative sine is positive sine x divided by cosine squared x, which is really sine x divided by cosine x times 1 over cosine x, which, if we remember our trig, 1 over cosine is secant, and then sine over cosine is tangent. So this is one that you should put in the files. The derivative of secant x is equal to secant x times the tangent of x. And that's the quotient rule. And for parts C, we have g of x is x squared minus 1 divided by x cubed plus 1. And so the derivative is going to be g prime of x is the denominator, x cubed plus 1, times the derivative of the numerator, which is 2x, minus the numerator, x squared minus 1, times the derivative of the denominator, which is 3x squared, and all divided by x cubed plus 1 squared. And so if we distribute, we're going to get 2x to the fourth plus 2x, and then we're distributing a negative 3x squared, so minus 3x to the fourth plus 3x squared divided by x cubed plus 1 squared, which, if we simplify, is going to give us negative x to the fourth plus 3x squared plus 2x divided by x cubed plus 1 squared. If you wanted to, you could factor in x out of the numerator, but it doesn't do anything that's very useful. So for option D, so it says find the second derivative. That's going to require that we do the chain rule as well. So we're just going to knock this down to first derivative instead. So we're going to get f prime of x is the same rule, the low function multiplied by the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. And so that's going to give us x plus 1 minus x plus 1 divided by x plus 1 squared. So if we simplify this, we're just going to get 1 over x plus 1 squared as our function. So that is going to conclude our video on the product and the quotient rule. Quick review. For the product rule, we're going to have, if we have functions 1 and 2, it's going to be the derivative of the first function times the second function plus the first function times the derivative of the second function. And then for the quotient rule, we're going to have the derivative of the denominator times, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. So again, as usual, do lots of practice. I'll see you all in class. If you have questions, please bring them to class.